Here in this video, we're going to learn about normal distribution. So in the simplest form, or we can say that in the layman language, we can simply say that it's a kind of visualization which shows the data, which shows that most of the data points in supplied data are near to the mean. Now, as we progress further in the video, I'm going to explain each of these things in very detail. Before that, just let me tell you that this particular thing is also known with the name of Gaussian distribution. It is also called the bell-shaped curve, probability distribution, and a special case of this normal distribution is also called the standard normal distribution, which further is also referred as Z distribution. Now let's move forward and understand what it actually represents and how it helps us. So let's take an example over here. Here we have the transactional amount for a given month in all of these following metro cities in India, right? And now we have to summarize this particular data set. So the first thing which comes into the mind is finding the mean. So after finding the mean, we can say that approximately each of these cities have transaction amount of 5 million. Now what next? If you look at these data points, are they actually 5 million? No. Then what we do is we find the standard deviation and then we get the answer of 2.58. Then what we can say is, though the average transaction amount in each of these city is 5 million, but that deviate from 2.58, that means the average difference from mean of the transaction amount is approximately 2.58 million. Now the question comes, what proportion of this data is deviating by how much of the standard deviation, right? Because this 2.58 is just one standard deviation, and if you look at this data point, this is apparently not deviating just by 2.58, or if you look at this one, this is of course not deviating just by 2.58, right? So what is the solution? How are we gonna solve all these doubts? Don't worry, here we're gonna have normal distribution. So let's try to understand what all are the questions on first stage this particular visualization of normal distribution can solve. So this middle point, it shows to the mean and median. So when the data is normally distributed, the middle point shows mean and median, but if it is right skewed or left skewed, it wouldn't say both of these two things, right? Now if your data has some numbers which is occurring multiple times, which is called mode, then the peak of this normal distribution or this bell shaped curve, if you look at the curve, this is resembling a shape of bell which you usually see in temples and something like that, okay? So the peak of this bell shaped curve represents to mode. Now if you look at this difference, this interval, this usually represents to one standard deviation. So you see all these many informations we got just by one visualization. This is where we create this normal distribution to answer all of these things by just one visualization. If you don't create this, you'll have to mention many points, but if you're creating just simple this visualization, the viewer will get all this information just by looking at this one single picture. Moving forward, here if you see the center point, that is representing to mean, which I just explained, right? And in a case of a standard normal distribution, what happens? Mean would always be 0 and standard deviation will be 1. So here we are taking an example and we are trying to understand how the data are segmented, data points are segmented in a normal distribution. So when your data is normally distributed, so what happens? 34.1% of the distribution will fall in the range of 1 standard deviation at the right from your mean. What that means? Means mean plus 1 standard deviation. Whatever range comes in that you're gonna get 34.1% of your data will be falling into that. Now, next, same thing, 34.1% of your data will be falling below mean. This is above mean and this is below mean. So in total we can say that 68.27% of total data distribution, the data points 68.27% of the data points falls in a range, the data points falls in a range of 68.27%. okay. Then moving forward over here, we can say that between first standard deviation and second standard deviation, the data points which falls, the proportion of data point is 13.6%. That's at the right side, and same happens at the left side. Now moving forward, in total we can say that 95.45% of the data points falls in this particular range, in range of -2 standard deviation to 2 standard deviation, or you can say plus 2 standard deviation. Moving forward, same case, 2.1% of the data points falls in the range of -3 standard deviation to -2 standard deviation at the left side, and same happens at the right side. So what we can say is 99.73% of the data points falls in a range of -3 standard deviation to 3 standard deviation. Okay, so this is how the data points are segmented in a normal distribution. Now if there is some data point which is coming beyond 3 standard deviation, those all are considered as outlier, and there are different ways to treat those outliers. It's not something that you directly go and remove that. So this was the theoretical thing. Now what happens when you apply this particular thing on your data sets, till which data point or till what all are the cities which will come in range of 68.27% of the data points, and what all are the data points which will come beyond that, and what all are the outliers. How is this thing going to solve our problem, answer all these questions? Now let's move forward and see. So here I'm creating a grid, and here the number of standard deviation. This is our default standard deviation, not default means the standard deviation which we calculated. Okay, now let's see the value of one standard deviation. The value of one standard deviation is basic standard deviation multiplied by 1, which is 2.58, of course. So let's apply this on our data. So if you see, mean plus 2.58 at the above of mean, this is the data range, and mean minus 2.58, so this is the data range. So this area shows that all these cities are falling in the range of 68.27% of the entire data set, and this is one standard deviation from the mean, minus or plus. Moving forward, this is your standard deviation multiplied by 2 means 2 standard deviation, which is 5.16. Now if you add 5.16 to your mean, this will come somewhere 10.16, and the data set will go beyond this limit, okay, because we have the data points till 9 only. So this is going beyond our available data. Similarly, if you subtract that from mean, this is also going beyond the data. Now if you go to the third standard deviation, then the value which you get is 7.74, and we don't have the data in for that particular range, because if you add 5, this 7.74 standard deviation to mean, which is 5, it will come somewhere 12.74, or same in the negative way, okay, but we don't have the data falling into that range. So this is how, using this segmentation, you can segment your particular data. I just hope that it was simple and clear to you. Moving forward, let's see, whatever we understand, how can we summarize our data. So to summarize, we can say that approximately the transaction amount is 5 million, and median or 50th percentile or second quartile of our data distribution is 5, because this is the normal distribution. So apparently when the data is normally distributed, whatever you find the mean value, that is equals to the median, 50th percentile or quartile 2. That's going to be the same. So by looking at this, you can say that 50% of the data is above 5 million and 50% is below 5 million. Moving forward, okay, before that, here is the I mean, what we can say, that illustration. So if you see 50% of the data falling above, below that, below mean, and 50% above mean. Okay, so this is the middle point of your data. So what we conclude is, when the data is normally distributed, mean and median both going to be the same. Then it comes average deviation from the mean is 2.58. So here we are saying that average transaction amount is 5 approximately, middle point is 5, right, and approximately the data points are deviating from mean by 2.58. This is, and all of these cities are coming in the range of 1 standard deviation, that is -1 standard deviation to +1 standard deviation. All of these cities has the transaction amount in this particular range, which is 1 standard deviation, that is 2.58, mean plus 2.58 and mean minus 2.58. So this is how normal distribution helps you to answer all these sort of questions. Further, it also helps you to find, when you are working in data analytics or data science, then you simply, when you are doing feature engineering, we use normal distribution to see how the data in a particular variable is distributed, and you can figure out the outlier, and then you can treat it accordingly. Moving forward, in normal distribution, I just hope that you liked what I explained. If yes, then give a thumbs up and write in the comment if you liked it. Moving forward, possibly I'll make a video which will explain when do we call it standard normal distribution, which is also referred as Z distribution, and what all are the real life problems which we can solve using the normal distribution. Thank you very much for watching the video. Until then, happy learning and all the best.